Hello and welcome to TelecomTV. I'm Martyn Warwick and I'm talking with Stephen Mellor, who is CTO of the Industrial Internet Consortium. Stephen, thanks for the time and for talking to us. The world's full of various sorts of professional bodies and consortia. Tell us about the Industrial Internet Consortium, where it came from, how old it is, who your members are, etc. And we'll talk about the machinery first and then talk about what your aims are.
Certainly. The Industrial Internet Consortium was founded March the 27th, 2014, with 5 founder members, which I always miss one, GE, AT&T, Intel, Cisco and IBM. And the interesting thing about that is that they cover the stack from applications at the, quotes, top, all the way down to the chip, and of course the bandwidth in the middle. So that, I think, is an important characteristic of the consortium. It was founded because these players found themselves repeatedly solving similar problems and working together because the space is so large that not one of those companies can solve it on its own. And as a result, they were working together here and then working together there, solving similar technical problems and similar business problems as well. And they also had the need to bring in other smaller players who have particular innovative technologies that could be of value to a particular project. So rather than solving the same problem over and over, they decided to get together, found the consortium, as I say, in 2014. And since then, the membership has grown quite quickly. The players are global. It's important, I want to emphasize that the IAC is a global organization, even though those 5 founder companies happen to be headquartered in the US. I see them all here on the floor. That would include companies like Fujitsu, Toshiba, Toyota, Alcatel, hundreds of them, Deloitte, Accenture, global companies, large companies, serious companies. But there's also a large number of smaller companies. This is quite deliberate. We are a membership organization with a for small companies at least, membership fee, very small, I think. And that was set deliberately to encourage small companies to join so that they would be able to work together with larger companies to fit in their particular technologies into a particular niche. So that's kind of the overall organization. There's now 160 members or so, last time I checked. For a while it really was, you had to check daily, but that's good.
What are the aims of the organisation? What are the goals?
Well, like many organizations, we have a lengthy mission statement full of good words.
Yeah.
But the ones that are the most important are the 3 at the end, transformational business outcomes. There are estimates that the Internet of Things, Industrial Internet, whatever you want to call it, could affect something on the order of 46% of global product. And when you're talking $70-odd trillion, that 46% rolls out to be $32 trillion, which is a nice chunk of change.
It certainly is.
Yes, I would like some. But some, of course, is an interesting number. If we could have a 1% improvement of efficiency across all of those sectors, then that's a very large amount of money.
Sure.
And 1% doesn't sound like a lot, but when it's spread across all these different areas, just reducing the weight of the device that holds your aircraft engine onto your airplane, that saves a lot of fuel. If we can arrange it so that the knowledge of the inventory in a grocery store is well understood and reduce wastage, again, 1% doesn't sound like a lot, but it makes a huge difference when it's deployed globally. You can do the same kind of thing when you're thinking about healthcare. For example, most devices in hospitals are unconnected, or if they are, they're basically providing information to the clinician of one form or another, but they're not connected to each other. So if, for example, you connected an O2 meter and a respirometer to each other, then that would reduce the number of spurious alarms that you get and the panic, of course, that causes with an anxious parent, for example. And if you could connect them, then you would know if both went off, then we have a problem. Whereas if one goes off for a while and then goes back on again, somebody moved. No big deal, right? So there's a lot of difference that can be made. And that 1%, when spread across all of the areas in which we could work, would make a huge difference.
What about in terms of security and technology then in this sort of area? I mean, security must be a major problem or opportunity, whichever way you want to look at it. What about that sort of area?
Yes, well, when the internet was invented, and Al Gore, I don't think, had very much to do with it, the primary purpose, this was at CERN, just not far from here, where now Sir Tim Berners-Lee wanted to share documents. That was the goal, between one accelerator and another, and one lab and another. And so security was simply not on the radar. It's just not on the radar at all. Of course, at that time, when some of these elements were being invented, and obviously the URL is just one of many things that had to be constructed, security simply wasn't really in the picture. It just wasn't there. But we also couldn't predict a lot of the things that we now have from the invention of those foundational technologies. So there's 2 points that I want to make. First off, security wasn't involved then. And secondly, that by having an open architecture then, at that time, we enabled a large amount of innovation, which could not have been imagined by any of the people doing that work. So to your question regarding security, it's very simple. We have to have it. Everybody knows that. We have, I think, a good number of ideas about what needs to be done about it. But the main thing is that it absolutely has to be a part of the architecture of the industrial internet. Fundamentally a part, not bolted on and not executed by obscurity or by wishful thinking. And this is going to be quite an interesting, let's just use that word, problem, because many devices are secure because they're locked inside a cabinet inside a chemical plant. Now, when you connect that by wireless, maybe, then you might connect it to this factory, but then you need also to be able to protect that to ensure that some person driving by doesn't gather data or cause you to affect something going on in that plant. So security absolutely must not be bolted on. It has to be a part of the architecture. It has to be inside, if you like, everything that we do. That means, of course, there's no single answer what are we going to do about security, because it's at the endpoints, it's at the gateways, it's in the communication channels, it's everywhere.
Okay. One of the other trends that we see, and a lot of wishful thinking around this as well, is the concept of interoperability. There's a lot of talk about it and a lot of wishful thinking, again, in regard to that. Sometimes it works, sometimes it doesn't. Is the IIC involved in any way in ensuring interoperability, and is that part of the purpose of the organisation?
Going from the back first, yes, very definitely. Going back to the beginning then, in your litany of issues around interoperability, I think that we might add, no one has a clear picture of what it is, or to put it a slightly different, perhaps more charitable way, many people have an idea of what it is, but they don't agree. For example, some people believe that interoperability is just a matter of defining interfaces. That's good, that's useful, that's great, that's helpful. But what that does not do is allow you to bring different technologies into different architectures. Because if you have one particular approach with an API, application programmer and interface, to that software, then it has to behave in a way that will fit into the underlying architecture. Simple example, you might have an API that says, call this function according to these patterns, away you go, and the expectation is that that will be called, right? Well, in some cases, what you want is for this to execute periodically, because you wish to poll the state of the universe. And the issue then is, how do you ensure that that happens, right? So, I mean, there's obvious answers. I mean, it's very easy. You make a little thing that calls it periodically. But the point is that they don't interoperate unless you have an underlying architecture, right? And so understanding how that fits into architecture is important. So let me go now into the middle. The issue, the way in which I see it, and I'm just one person, of course, and there are many experts in the IIC who will tell me how it really is, but the way in which I see this is that it has a lot to do with orchestration, how it is that you connect one element to another. So as we go into more autonomous devices, as we go into things that will have to patch themselves and understand how they connect to other people, then we'll need ways of being able to say, I'm here, I do this, and this is how I do it, and here is my interface. If you want to use these services, this is what you have to do. And that's a far more complicated statement, I think, than just saying, oh, we need to define interfaces, which obviously is important.
We'll have to round out the interview now, Stephen, but I'd like to finish by asking you, so as far as the IIC is concerned, what is your next step? Are you still recruiting members? And how do you formalise the organisation such that you know what work is being done? Are they producing standards? Are they producing papers? What is the sort of end result that you can then work on to go forward?
Okay. Well, let me start with an important thing, because unfortunately this is frequently misunderstood. The IIC is not a standards organisation.
No, I thought not.
Right, we're not. Just not.
Right.
Whatever you read in the newspapers, we're not.
Right.
So there's three main initiatives, and it's important to understand all three of them to see how they connect together. The first one is the ecosystem, getting people together that understand problems, have knowledge, that wish to work together on real business problems. The second is technology and security. We have to have an open architecture that is secure and private and allows for interoperability, however we end up defining that. The third step is test beds. It's no good writing papers if what we need is products, and the way you build products is by building stuff. So the test bed side of the world has two elements to it. One of them is an engineering thing, which connects to, if you're going to build something, it should conform to the kinds of things that we've been talking about in terms of open architecture, etc. The second thing is funding from within different member companies and outside to government agencies and to academia, which goes back into the ecosystem part. So putting those three together, the main output is innovative products. That comes from having test beds that allows us to test stuff. What is that stuff? Well, now we're back at standards. While we do not make them, we do have a lot of expertise in our member companies in respect of what we need. So what we're doing is, roughly, defining an industrial internet reference architecture, which I believe will be published shortly. There was a meeting just yesterday, but I wasn't there. That is going to lay out essentially the boxes, if you like. Think of it as the rooms in a building. This is our architecture. And then within each one of those rooms, we can identify furniture that already exists. And so we can put in a standard here and a standard there, and then look at it and say, well, mixing my metaphors horribly here, there's a missing table. Can't have a dining room without a missing table, so we need a table. And that leads us to the next part, which is to write requirements to standards organizations that say, we have a need for this to make that work, this is why, and then we can go to the experts in each one of the different areas. It would be silly, I think, to reconstruct all the work that the ITU does. Let's instead go to them and say, these are the things we're trying to do. Can you help us do that? And then, of course, we can test that in the test beds and go around the cycle again and have lots of fun.
Okay, really interesting, fascinating stuff. I hadn't heard of the IIC until today. I had no idea how big it is. Stephen Mellor, thank you very much indeed.
Thank you very much for the opportunity.